Here, and assembly.
Yeah, hi Sandhya, hi everyone. Sandhya, could you please confirm if my voice and voice is clear? Great, great. Hello everyone. Very warm good evening. I'm Shansi Rani, the head of services at Course Divine, a premium edtech platform committed to transforming faculty development to innovative, affordable, and outcome-driven learning programs. At Course Divine, our mission is to empower educators and professionals with high-quality, structured courses that bridge the gap between academic theory and the real-world applications. Our vision is to make continuous learning accessibility to all, helping faculty and institutions stay relevant to the faculty to the future-ready programs. As head of services, I oversee the planning, execution, and delivery of all our programs. I work closely with our academic and industry partners to ensure every course is impactful and relevant and aligned with national education standards that are there right now. And we have to talk about Course Divine. We offer UGC compliant faculty development programs, refresher courses, and skill enhancement workshops designed with a learner-first approach. We are trusted by thousands of educators across India and across the globe. We are known for academic rigor, accessibility, and responsive support. If we have to talk about the unique feature that makes us stands out in the market is that we proudly offer a one-to-one learning platform, enabling direct interaction with top faculty and industry experts at a high affordable cost. This personalized model ensures tailored feedback, deeper understanding, and maximum value for every learner. So if we have to talk about the key highlights at Course Divine, the courses led are by IIT and NIT professors and seasoned industry professionals. The courses are also very well structured by following the UGC and AICTE aligned content with certification. We offer the prices which are very affordable and end-to-end learning support. The strategic partnership with ESL IIT Tirupati makes us stand out, which is also provides a lot of innovation focused courses, right? So I'd like to welcome you all to this 5-day FDP program starting today from 5 p.m. to 6 p.m. Attendance is mandatory for certifications. Certifications will be issued within 48 hours after the program completion. For any queries or assistance, please reach out to Sandhya, the assigned coordinator for this FDP. We are really excited to have you all on board, wishing you a very great learning experience ahead. So today we have Dr. Anil Kumar, an assistant professor in the Department of Mechanical Engineering with research experience from IIT Puducherry. His work focuses on assembly and disassembly, sequence planning, human-robot collaboration, and the integration of augmented reality in manufacturing environments. So his primary research interests include EOL, end of life, product disassembly, sustainable manufacturing practices, and the development of optimization algorithms for automated planning systems. He has published extensively in reputed journals such as Sadhana, Assembly Automation, and Engineering Science and Technology. He's very well recognized for pioneering methods that enhance the feasibility and efficiency of assembly and disassembly operations. He continued to drive progress in Industry 4.0, bridging theoretical research with practical applications in robotics and sustainable product life cycle management. I believe with his experience, he would be able to deliver the most important information in the today's session. I would like you all to be very interactive, and once the session is about to end, you can also post your questions in the chat feature so that Dr. Anil Kumar would be able to address all of them. So I'd like to request Anil Kumar to take over the stage. You can start sharing your screen. Sandhya would be here to make sure that the process of the entire FTP is going smooth. Anil sir, you also can reach out to Sandhya in case of any queries. Thank you, everyone. I'll again see you all on the day 5. Thank you. Bye-bye.
Okay. So sorry guys. Actually, just now I think the voice is clear. So I'm very thankful for Jansi Madam for the brief introduction over me, and I want to thank Post Divine for offering this session and giving a platform to share my ideas over the emerging technologies. And I personally want to thank you, Sandhya, for creating a platform and assisting all the activities and follow up the things. So without wasting the time over briefing me, I'm directly going into the session. And the question answer session will be for the person for the person hours you could interact with me in the chat feature. At the end also, just you could ask me the questions. If meanwhile if anybody wants to interact with me, you please use the chat feature. So I will try to resolve the things. If I'm unable to answer in this session, just I'm ready to share my thoughts with you in through my mail mail and different platforms also. Okay, the research is always research is like an ocean. So within 1 hour or 2 hours, we couldn't resolve everything. But I'm ready to share my knowledge as what I'm having. At the same time, if any new interesting feature is popped up in your mind, maybe this is a good platform to share over ideas also with me. Okay, so out of my experience, I'm going to carry the session over the industry 4.0 and other emerging technologies. So right now, just I'm trying to share my screen. You please confirm. Yeah, I will share. It. Yes, I hope this. Yes. So the title of the session is the foundation of emerging technologies. So in this way, I'm trying to brief out the different kinds of contents. So this is comprised of the 11 topics, and at last we're kind of trying to finish with conclusion, and that conclusion will cover whatever the research gaps and challenges in the future, that the future challenges and the research directions are existed in these different kinds of areas. Meanwhile, I will try to communicate whatever the possibilities could be the extent in the every research area. So first I will start with the industry 4.0, and later whatever the artificial intelligence methods right now we are developing and applying further in the further industry 4.0, and later 3D printing and additive manufacturing and the sustainable engineering practices. Right now it is a very much important for every developing and underdeveloped country. So even the economies of the country is also going to be decided with this factor. And next, the Internet of Things, augmented reality and virtual reality, nanotechnology and advanced materials. Even though it is so far, the technology has been started and the research in the materials also been carried forward. But still, whatever the challenges are left that I'm going to discuss here. And next, digital twin and cyber security and the big data analytics. So the 11th session is about challenges and the future directions about these areas, and how the immersive technologies and the emerging technologies playing a role in our academia and the industry. So those things I'm going to share in this session. So if I'm a bit faster, you please let me know. Otherwise, just I will I will go forward. See, every country's, but yes, whatever the country is, every country's GDP is dependent upon the exports and imports. Right now, even India also facing different issues regarding the manufacturing to turn that into the manufacturing hub. So recently, you could see that the US president he used to put different taxes over the environment, let me say, Indian market. So what are the things actually just we're going to export? They will give what are the things actually just we're going to export and the import at least 25% we have to pay. Of course, that is limited for the some kind of products only, but still, in order to save an economy of a country, the President Trump used to put the taxes over us. Similarly, every country economy is dependent upon the exports and the imports. Suppose if a country is able to export more and import less, then we can say that is an economically strong country. And being a world's largest fourth economic country, India having different kinds of challenges. Even the Honorable Prime Minister Narendra Modi ji also giving the various incentives and the different ministries also offering various schemes to encourage the productivity in different kinds of sectors. We have the majority at present from the past 4 years. I am observing that the applications in the developments in the army, the ammunition sector, it is developing. And then if you see these are the okay. So India is the world's fourth largest economy, and we have the 140 crores of population, and that to 50% of population are with the youth, and these can be the consumers. If we are able to turn them into the entrepreneurs, that could be the impact will be the more. And the third thing, we have a different kinds of advantages like in the area. World's seventh largest country, of course, nearly some 50% of the land is fertile, and the other 50% is available for the taking industries and starting up the industries and improving of the any developments. And further than the living standards, so India is having a diverse kinds of living standards. The rich, middle class, poor people, and the below poverty line people are existed, and even upper poverty line also people are existed. That means when the variety of standards are existed in the economy, that means we are creating a market for selling of different kinds of products at different costs. We can see that a telephone, or just means a mobile, we can purchase up to, that means India having a feature to sell a mobile phone of 1 lakh at the same time for 4,000 also. That means the market is growing. At the same time, we have different kinds of capabilities to capture the market. And fifth one is the transportation. We have the largest coastal region, so thereby we can export and import the products. And sixth one is technology adoption. Comparatively, compared to the other countries, India is having higher technology adoption rate. Recently, we have seen that UPI once upon a time, even the ministers also suspected whether this will be possible or not. But right now, we can see how the UPI transactions are going on, and how the people are using the social media platforms, how make the platforms be easy. So if we use such kind of technology adoption for increasing for penetration of the emerging technologies, that would be a great benefit for the both industries and the academics and the personals also. In this way, we have to use the technology adoption, and whatever the emerging technologies are existed, and in which way the challenges are existed. So that challenges we have to look as a part of academia and the industry persons also who are joined here. So you could observe whatever the potential scale of adopting this kind of technologies. So, and then the cultural diversity, this is also a benefit. So these many things are existed these many things are actually existed to create a very good platform for the marketing. At the same time, manufacturing hub also. So right now, the India's target is to convert the marketing hub into manufacturing hub, right? But even though just many people are literate, even the literacy rate is higher, but the adoption of technology, if we increase, then we can convert the marketing hub into manufacturing hub. So right now the world is moving towards the industry 4.0. So here I'm giving the brief discussion about the emerging technologies. See here, the engineering field is undergoing an unprecedented transformation. Compared to the previous decades, right now we are in the phase where the unprecedented transformation, like suppose for the 4 years back, whatever the language programs are available, that means like stack Python, Java. Once upon a time, to convert from C to C plus, how much time is taken? Now, after the Python, how many kinds of machine learning technologies we are adopting? So this is the unprecedented transformation driven by rapid technological advancements. These technological advancements are not limited only for the India, even for the world itself. It is observing the technological advancements. So these advancements are emerging from the smart materials to advanced automation, and the core competencies are essential for innovation and competitiveness. Understanding these shifts is very much crucial for every engineer in India, whether it is an academician or the industry person. It is very much important to adopt the technology. So now, why it is important? Because machines are learning and factories are thinking, and the engineers must evolve. So how machines are learning, that I will explain in the next slide. That is about the industry 4.0 and how factories are thinking and in which way the engineer has to be developed. The entire theme will be revolved around this only. So first I will go with the industry 4.0. So the in the industry 4.0, the new tools for the generative design and simulation are for optimizing the product development like never before. So suppose if you take any product, the product have product development stage, manufacturing stage, marketing stage. So these are the 3 stages, and every company or industry has to taken care of. So earlier we are observed that in the 1980s up to 2000, different design strategies are evolved, and at that most of the time they used to spend over the design and the product development phase itself, because after releasing a product into the market, the industries are evaluating the feedback from the customer and then trying to implement that in the products. So these kind of feedback they used to collect from the surveys or from some enterprises. But now the social media is very much available, so the feedback is very much attentive. At the same time, how the feedback is affecting and how the competitiveness is developed, in the same way we have to improve the productivity and we have to catch the competitiveness. In order to catch the competitiveness, we have to minimize the time over the product development phase. For that development stage, so we have a tools for generative design, and the simulations also supportive to understand what kind of impact a product can create, or with this small change, how much of variation or impact can be created in the product that is available. So later that, if the evaluating these kind of things in the product development stage itself, it can increase the product efficiency and the transforming the manufacturing from conventional to the advanced. So how it is advanced, I will explain the next slide. See, in the industry 4.0, earlier actually either robot and human is able to work in the separated manner. If the human is working at somewhere, the robot is not allowed to work at the same place. But right now, the robots and the humans, those two are collaboratively working, and that leads to a new field that is called human-robot collaboration. So in the human-robot collaboration, so the tasks are allocated for the both human and the robot based on the workability. Suppose if a if a part cannot be handled by the human, either by its weight or the temperature or the complexity or the sharpness, that task will be given to the robot, whereas the human intelligence or existing to the environment and the over human intelligence or the decision making, those things will be considered, and based on that, the task will be allocated. So in the human robot collaboration, right now we are moving towards the producing the cobots. So these cobots are designed to interact with the human workers safely, and cobots can take on repetitive and hazardous tasks. For example, if a robot and human is allowed to work in a same place. Robots have different kinds of robots can have. We have the industrial for this context. I'm discussing about the industrial robots only, not about the humanoid robots. If the industrial robot is allowed to move, like if you take a Puma robot or Scara robot, Scara is nothing but the selective compliance articulated articulated robotic arm. So if the robotic arm is to rotate in this direction, at the same, suppose if the robot is to use to move in this direction, even though the human is working. So right now, whatever you can see, instead of the humanoid robot, if you see any industrial robot used to work over there, if the robot is allowed, it wants to move the object like this. If the human is not ready to understand the dynamic environment, at that time the accident might occur, because the high payload robots can cannot interact with the human, because to achieve their task in the accurate mode and the due to repeatability, they couldn't stop immediately. But at that time, accident can happen. But how can we minimize such kind of robots? Means by providing the safety enhanced sensors. That means self restraining robots or self braking robots. So those robots should have enough intelligence to observe the human identity and how the human will react. Suppose if the human is facing any fatigue or he is facing any difficulty, that the robot has to understand, and in such a way the robot and the human should collaboratively work. So right now the research is very much encouraged in the human robot task allocation. So based on the work, based on the load, based on the temperature, and different kinds of factors may work. And based on the application also, human and robot can collectively work. So in which way the human and robot can, the human robot collaboration can be diversified. Sorry, the research over the human robot collaboration can be what I can say, can be directed. So right now the human robot collaboration, task allocation, there is a wide possibility for doing the research. And human robot communication, suppose if you want to control your robot in the through your voice. Suppose if you want to communicate the robot with your voice, maybe in the industry, some uninterrupted voice might arrive. At that time, which command the robot has to take? So the noise filtering systems, is very much needed for the collaborative robots. In the another way of communication, through gestures. Suppose if the human, how we used to interact with the deaf and dumb people through the sign language, they used to make different kinds of signs like this, by raising one finger or two fingers, or with this kind of sign. So by making this kind of tilts, so how the deaf and dumb people will be directed or communicated. In the same way, through gestures also, robot can be communicated. So what the best gestures and how a robot has to identify. Suppose if a human have the every human have different kinds of different kinds of finger sizes. So the robot has to identify whether they are raising the hand and what is the finger size and what they are indicating. So in this way, the gesture control robots has to be communicated for identifying and improving the communication. So the gesture control can be improved. So through voice, through vision, and through gesture. So these communications can be improved. So in this way, the research can be directed. So before going to the next slide, so let me explain how the increase the productivity.
I'm so sorry to interrupt you.
Tell me.
Sorry to interrupt you, but can you please put it in presentation mode? And it's stuck in the first slide, so we just want to re-verify if the screen is visible.
Yeah, it's just I kept in the presentation mode only, ma'am.
No, sir, it's not in the presentation mode for us. Can you click on F5?
Yeah, wait, ma'am.
Yeah.
Is it available in the presentation mode, ma'am?
No, sir, it's still on in the PPT mode only.
Right.
Can you please stop screen share and present again?
Yeah. Yeah, I have stopped the screen sharing, ma'am. What I have to do now?
Can you please share again? And
Yeah, please. Okay, okay. I will. Yeah. Is it okay, ma'am?
Yes, yes. Now it's visible. Thank
Yeah.
you, sir.
Okay, fine. Thank you for confirmation, ma'am. So how the how the human robot collaboration can increase the productivity? Right now, I have discussed that automation, the automation of the things can reduce the human error and increase the throughput and allows the 24/7 operation. The human difficulty or the for performing a repeated number of tasks and fatigue also might occur. So these fatigue and different kinds of ergonomic issues can be avoided through the automation and the increased safety also. So by putting the robots over the hazardous environments, you could improve the safety in the industries. In such a way, we can achieve the productivity with safety. At the same time, the robots can be used to increase our productivity. So how can we increase the productivity? Right now I have discussed through human robot collaboration. This is a broad research area, and the potential for doing research is higher. So here you can see the challenges in research, the legacy integration and the cyber security. So how it will be in the industry 4.0, the machines used to communicate the information, and they used to filter the information, and whatever it is needed for the to performing the operation, that can be trained with by the machine itself. For example, an intelligent robot used to observe something from the application. So that data is stored in the cloud, and that information used to share by the other robot. For example, this is a one kind of communication and the cooperation between the robots. For example, half of the task is done by one robot, and it has to move forward to the another robot. So this information is shared by the robot itself to the another robot. In this way, in the industry 4.0, the machines used to communicate. So how this communication can be improved means through the sensors and designing the mechatronic lines and closing the loop between the simulation and the shop floor. And the key trends are digital twins. So right now I have another slide for discussing about the digital twin. So right now just I have discussed about the cobots and the predictive maintenance. So to regulate the workflow, we have to go for the predictive maintenance and then autonomous intra-logistics. What are the logistics are existed, like the time, work, and the task allocation, and the material information, and how the productivity is going on, and what are the shop floor. So these all things will come under the intra-logistics. If we are able to connect everything, that will increase the productivity by reducing the losses. So in this way, industry 4.0 is an emerging research. So the emerging technology and the research is encouraged through the digital twin and the human robot collaboration. So next is AI in mechanical engineering and augmented capabilities. So you could see the artificial intelligence. That means the how the nature used to react over different kinds of process. The logic is taken and developed that logic for the optimization process. So that is called the AI. Even during the performing the assembly and disassembly in my research, I used to apply the genetic algorithm and particle swarm optimization method for getting an optimal solution. AI has an extensive feature to understand the dynamic situations and do complex calculations at by reducing the within the less time. That means AI can do the complex calculations in the less time itself. So thereby the logic, whatever we are developing to understand the dynamic environments in the industry, that can be helpful to solve the problem within minutes itself. For example, if you apply the AI method over the predictive maintenance, the predictive maintenance is nothing but the whatever the problem might occur if the machine is running continuously. For example, if I used to apply AI for my bike, okay, instead of a fuel indicator, if I used to apply, so if I go for this much of speed, and in some false road, some kind of some jerk existed roads. So if I go for such the whatever the quality of the petrol and what is the condition of an engine, and what is the condition of the road, and what is the speed I am trying, and how much of frequently I am changing the engine oils. All these things will be calculated by the all the data will be collected. And if we give that data to the AI, if I give that data to AI, so definitely the AI can tell us after 10 kilometers or 20 after 20 kilometers, definitely your vehicle is going to stop. So thereby you have to change your engine oil. Like that, in such a way, a AI method can instruct us. So this is called the predictive maintenance. So by collecting the data and AI used to analyze, and that logic, whatever we are developing, that is collected from the nature itself. So far different kinds of AI methods are existed. If you see in the Google Scholar, you could see the genetic algorithm is popularly they are using, and artificial neural networks, and the particle swap optimization, and quality colony optimization, and elephant swarm optimization. Different kinds of optimization algorithms are existed. So based on the application, we have to select the an AI method, and still the gray wolf flower pollination algorithms are existed, gray wolf algorithms are existed. So still there is a chance to propose a new algorithms to solve the real-time problems. So there is an option to improve the option to improve the quality of working. And see here in the challenges, so what are the key trends actually right now? The machine learning, reinforcement learning, these kind of trends are existed. And the challenges in the research are to improve the data quality and analyzing it, and hybrid physics for the machine learning models, and want to create a trustworthy AI for safety critical control. That means AI should not be tampered or hacked with something, because because the cyber security is also very much important. Otherwise, the information hacking from the industry, it can lead to severe losses. Entire production line can be disturbed. So in such a way, the trustworthy AI methods are needed. So in this way, the research in AI is needed, and the additive manufacturing and the automation. One benefit I have observed in the additive manufacturing is the complex geometries which cannot be created within days or a month by a conventional manufacturing methods, because of the problems with the machining techniques or the tool availability or any other factors. But still such kind of complex geometries can be created through 3D printing technique. Earlier some polymers only we have used. Right now metal 3D printer techniques are also available. So when I was in the NIT Puducherry during my research, I have seen a metal 3D printer. Of course, the cost of metal powders are very much higher, but still there is a possibility to create intricate shapes. That means complex shapes. It can move the prototype like anything. If you want to check a model, whether it is delivering the sufficient output or not, even though we can trust the simulations, but the accuracy from the simulations is 90% only. So if you want to check everything to be assured, that means if you want to assure for ever the running of the process, you can use 3D printers to check your models. So in such a way, the rapid prototyping can be used, and mass customization. This means the production can be happen in the flexible production and the mass production also. So if you want to, suppose if you take a mobile phone example, so mobile phone manufacturers, they used to release some lakhs of products at a time. So this is called the mass production. And how the customization can be happen means, if I want to change a single feature in a product, so thereby I have to change the tools and the manufacturing methods. By 3D printing techniques, we can achieve the mass customization by real-time checking. Right now, the challenges are multi-material printing. That means the composite materials right now, what we are producing, that is not ready to take in the metal powdered form. So whatever the powder form material we are giving to the 3D printers, that is existed in the powder form only. If we are able to provide that in other forms also, that will be benefited to the industry and the research. And the repeatability is not possible, and residual stresses also, that is right now the issues existed. And research is moving towards the proposing a research area like design for additive manufacturing, And in future, the design for nanomaterial production also can be a possible research. The 3D, for especially the design is meant for the 3D printing. So that means whatever the stereolithographic techniques and how the data, how the model is changing into the, sorry, how the model is, we are right now we are saving into the compatible format. So maybe the design softwares are right will provide us kind of feature to from designing stage to directly printable in the 3D printer. So in such a way, the future engineers has to understand the prototyping process, and in this way, like multi-material printing and reducing the residual stresses and ensuring the repeatability. And this is the possible way for research in the 3D printing. And next, the most vital, and currently every country is looking into this, sustainable engineering towards net zero future. Net zero means simply the thing is, right now, suppose in my research, I have taken the e-waste management. Like suppose if I take a mobile phone, I have used it, and after its end of life, I have thrown into the environment. If I throw into the environment, the materials in the mobile phone, or we can refer that as an e-waste, can pollute the environment. It has a capability to create the hazardous and disturb the groundwater pollution, and it can be potential problem for the aquatic and human life also. Especially in some countries like China, I have studied the research papers, and I have confirmed through the newspapers resources also. That means maybe in some research papers there is a possible manipulation is existed. Of course, that can be the predictive techniques can also be, it is possible. But after confirming the newspapers and the medical reports, I have observed that even in human placenta and the breast milk, heavy metals are existing. Heavy metals like lead, hydrogen, like mercury, arsenic. So these kind, that means cadmium. So these kind of harmful and hazardous elements are coming into the breast milk. That means the groundwater food is polluted because of the e-waste. Because of the e-waste. So right now, every country is producing that means proposing a laws like extended producer responsibility. That means the manufacturer, not only he used to fix about his production, he has to assure after its end of life, he have to collect the product. It means he has to take back the product, and he has to organize the materials, and he has to treat the materials, and that material should be used in future production, in future manufacturing. Maybe in future, the every manufacturing industry will face a issue like some materials will be given for the manufacturing industry, not the direct tie up with the mines, because extensive mining also can lead to environmental hazard. So some material will be given to him, and that materials he has to use for the product for the production. And after collection, after the end of life, they have to take back the product and use the materials for the production. So in such a way, we will going for the net zero future. The net zero means the environmental degradation or the environmental hazard. They're trying to make it zero. So that is called the net zero. And sustainable engineering, that means instead of only concentrating over the environmental objectives, you have to consider the economic objectives, because profit is very much important for running of any country. No industry can run with the losses, because lakhs of people will depend upon their profits only. So we have to consider the economic issues and the social responsibility and the social aspects also to be considered. By adopting the cobots and the robots, maybe by AI, by adopting the artificial intelligence technologies, maybe some jobs will be laid off. But we have to assure the employability and the improving the standards of human living. So that things will be covered in the social aspects. Of course, only the life cycle analysis and the sustainability will going to be another session. That session I will take in the last day of this FDP. So more details I will discuss in the that session about the sustainability in that session. So these are the different kinds of environmental risk indicators we have to understand. So for example, for production of 1 kg of propylene, 2.18 kgs of carbon dioxide is releasing into the environment. So whatever the one means 1 kg of carbon unit, okay, 1 kg of carbon dioxide is enough to rise the temperature of the globe at some part. In recent information, I have seen that nearly 5 kgs of carbon dioxide emissions are enough to increase the Earth's temperature by 0.001 degrees centigrade. That means 5 degrees. That means 5 kgs of carbon dioxide is enough to increase the Earth temperature by 0.001 degrees centigrade. Of course, the data is appearing like okay 0.001, and of course, so many factors are involved. But how many kgs of carbon dioxide is going to release for the production of propylene itself? Think about, for example, I want to I want to produce 1 ton of the propylene, and nearly 2,180 kgs of propylene. That means the kgs of carbon dioxide really can be released for 1 kg production of the propylene itself. So similarly, how many polymers are existed, how many metals are existed for the future manufacturing, how much of carbon dioxide we going to contribute in the environment. So these all things we have to consider in the sustainability. So these are the different factors like acidification, abiotic depletion potential, human toxicity, and the eutrophication. So these are the things we have to consider in the life cycle analysis. Right now, I have shown the 5-point indicator in the life cycle analysis. So in the life cycle analysis, 18-point indicator methods also there, and 23-point indicator methods also there, and how we have to conduct the life cycle assessment for one product, and how these things will be evaluated. That I will discuss in the last day of the session. So fifth thing is Internet of Things. By integrating the computers with the Internet of Things, we can use the real-time monitoring. We can use it for the real-time monitoring. So if the different systems are connected, means different robots or different machines are connected at a single line, whether the production is going on the right path or not, we can see. Suppose even in the agriculture also, if we want to integrate with the IoT, so we can have a prediction over the how the crop is growing to, whether it is going to fall or it is going to give a better it will come in the better production, like whether the cultivation is coming with we are going to give the profits are going to be in the losses. So that can be observed through the Internet of Things. If you are able to connect everything, like the irrigation, that means like the plantation, and how the plant growth, and how that means that means spraying of the maintenance of the plants. If all these things are connected, definitely agriculture never face losses. Right now, the countries like Israel going to adopt, that means not going to adopt. So they're adopting the Internet of Things in their agriculture. So that's why the farming in the Israel is very much higher compared to the India. Right now, in Indian context, nearly some 55 to 60% of people are dependent upon the agriculture even today. Even though the literacy is this much higher, even though many people are preferring the software, that means IT will get jobs and the white collar jobs, we can say that is white collar jobs. Still 55 to 60% of people are dependent on the agriculture either directly or indirectly. Because India having 140 crores of population, we need to satisfy our hunger needs. Definitely we have to adopt the technology. The technologies like drones and the Internet of Things can improve the productivity in even the culture, like that means the application like agriculture. Even the medical sector and the pharma sector and the textile, you can use the Internet of Things. So right now the research, that means how the research can be directed is interoperability. The sensors should support the proper feedback, and the sensor should give proper feedback, and the activators should be support the feedback process, and the life cycle management. This can be a potential research, and the power management. Right now, wherein the research is very much required over the ultra low power architectures. That means where the power consumption should be low, at the same time the productivity should be high. In such a way, the Internet of Things, the research of the Internet of Things is needed. Next, AR and VR, it means augmented reality and the virtual reality. There is a difference between the augmented reality and virtual reality. but how the industries can be used, it means, okay, you can see for performing of the simulations, the performing the simulations to observe what the process is going inside a prototype, that you can use. And for the training, especially for the training, for the skill development, this is very much needed, AR technologies. And the research is going on over the giving skill training. How can we use to how can we improve the learning techniques? Even the some schools also trying to adopt the augmented reality techniques. Instead, earlier we used to go for the some traditional sketching techniques. Later we goes for the 2D interactive techniques, like with the through projectors, through running videos and giving the some real-time observations is we're trying to provide. But the AR that means taking of the AR can provide, can bring a revolutionary changes in the learning techniques. For example, it has day to day, how much of we can see that one day, that means for the 2 years, whatever the technology is for 2 years back, whatever the technology is at the demand in the software industries right now, that may be in the demand or may not be. Similarly, how the world is trying to adopt the changes, and the human has to ready to learn the new skills every time. He has to update their skills. So to increase the learning experience, we could use the augmented reality and the virtual reality. So the IR can be used for real-time monitoring. And the next thing, whatever the how the research can be directed in augmented reality and the virtual reality is. So the softwares right now, whatever we are using, like Euphoria or the metadata or some other means holograms, such kind of lenses, some such kind of HoloLenses, such kind of softwares are there. So we can increase the productivity and the reducing of the computational time and the computational cost, and reducing the cost of the software. So that is a possible research. At the same time, right now who I'm describing in the image, a person having wearing the AR glasses. So the reduction of the cost in the AR glasses, the lens, improving the productivity in the lens itself. So those things can be improved. So in this way, the research can be developed. So, and the next thing is nanotechnology and the advanced materials. You can see the nanotechnology is a revolutionary technology in the 21st century. And of course, in the 20th century itself, the research over the nanotechnology is started. But right now, we are directly using the nanotechnology in the various applications. For example, in the medical applications, while you are creating the stents, the stents would be in the millimeter size only. But if we are able to create such kind of stents at the nano size, definitely whatever the blocks are existed in the arteries, the human, that means the human arteries, the blocks can be created through a nanomaterial. So the blocks can be resolved through a nanomaterial. This is the one example regarding the nanotechnology in the medical sector. Even suppose if I am able to manufacture this shirt with the nanotechnology, that means the distance between the fibers, if I able to reduce into the nano size, so I can use this shirt in the multiple times with limited maintenance itself. Without washing, simply by just dripping like this, I can take out all the dust, and I can use that means that shirt for multiple number of times. Okay, the product life can be increased through the nanotechnology itself. So, okay, most of the people are known about how the nanomaterials can be used in the materials. Like suppose if you want to create a nanofluid, so adding up the nanomaterials into a conventional fluids like a petrol or the diesel, we can improve that. We can convert that into the nanofluid. So in the applications like that means maintenance and the lubrication, such kind of applications directly we are using the nanomaterials, especially for creating some kind of tools and making up the ornaments itself. The tools made up with the nanomaterials. The tip, whatever the tip actually I'm showing, if you're able to manufacture the tip with the nanomaterial, definitely the productive, that means the surface finish will be different and the surface roughness will be less. At the same time, the quality of the surface finish will be more improved. So thereby productivity can be improved. In such a way, the research over the nanomaterials is started far before, And even today, the researchers going like anything. So the challenges are like scale up cost is higher, and the reliability. If we are able to provide the reliability over adopting the materials, so thereby we can take the nanomaterials application in different diverse fields. And right now, just whatever the nanomaterials just we are taking, and how the composite materials we are making, so those are non-recyclable. If we are able to produce a recyclable composites with the application or usage of the nanomaterials, definitely it will improve the product life, and it will increase the production process. At the same time, it is a outstanding research also. So next thing is digital twin. So some similarities are existed between the AR and VR technologies, but comparing to the AR, digital twin having the more and most accessory, not only more, most influence over the product designs. AR means it will giving a virtual platform like nothing is existed real, so human can interact. But here in the digital twin, the AR and the meta models can be interacted, so we can perform the live simulations. We can observe it for the that means for the preventive prevention loss of the materials. For example, if you take the Rolls Royce company, they use the digital twins for the to analyze the motor jet engines in real time during the flight. So even that AR is okay. The AR and some commercial platforms like ANSYS and KTR, these platforms are giving us so many simulations. But those simulation, the accuracy from the simulation is about 85% to 90%, and the result, whatever we can obtain from the some such kind of platforms, is valid up to 80% is only, and the reliability are also very less. But implementing by taking the digital team and adopting such technology, you could have a real-time interaction with the models. So this system processes thousands of parameters for the predictive maintenance and prevent failures. And we can simulate the real-life flight conditions, and you could use the digital twin for optimizing the fuel efficiency and enhancing the operational safety. So the digital twin, right now, the technology is increasing. At the same time, companies like the highest, very limited companies, and who are having higher turnover, those people only adopting the digital twin technologies. If we are able to bring such kind of technologies in up to the micro scale level, definitely the manufacturing phase will be benefited and production will be improved, and thereby India can be converted into marketing hub to manufacturing hub. So in such a way, you can use the digital twins. The challenges are like ensuring the model accuracy is needed and the data synchronization also. So how that model accuracy is needed means, for example, if we want to develop a product in any design platform like KTR, the SolidWorks, or any AutoCAD, we used to take some kind of flexibility for the designs. We cannot model any wired connections and all in the such things, and the different modules we have to go with that. But so whatever the flexibility we have taken, or the creative liberty we are taking, the flexibility is not a good thing. The creative liberty we are taking, so that creative liberty can reduce the accuracy in the solution. By using the digital twin, we can improve the model accuracy, and the data synchronization also very much important. So right now we are facing the troubles with synchronizing the data. So if anybody wants to interact with me about how the synchronization is not working, I can explain. So right now, just I'm moving to the one more slide. This is about the cyber security and the big data analytics. So my knowledge over these two topics is very limited. But now why I'm bringing these things means these are also the possible emerging technologies in the research, where the cyber security, how it is needed, I have already explained. Now when the industry, that means when the robots are communicating one information to another, so some person used to tamper the data, definitely it can cause a huge losses in the production. And the big data analytics means, so when the machine is collecting the data, every possible data also it will take. Every possible data also it will take. So we have to, the data filtration should be needed, and how much of data is needed for the further things, and for handling such kind of huge data, we need sophisticated systems. So the challenges are like existing in the data governance and the labeling cost, and biasing the data is a possible research, and casual or experimental machine learning techniques, and privacy and preserving analytics. This could be a possible research in the big data analytics. So these are the some what are the broad challenges existed in these fields are skill gap is existed. People are how much of intellectuality is existed in the human, but still the learning ability is very much low. So by using the AR technologies, we can improve the learning abilities. But to update the AR technologies, that some potential research is needed, and lifelong learning also should be encouraged, and industrial academic collaboration is also needed, because right now the R&Ds from the industries are different and academia are different. Once I have seen that Elon Musk, he directly quoted that how many research papers are appearing in the Google Scholar. So nowhere actually I'm going to use such kind of research papers, because I'm not trusting the such kind of data. So such kind of bottlenecks or the trust issues should be eliminated by encouraging proper collaboration through the industry and academia. So this is the possible way we have to improve. And finally, I'm concluding that integration is a key. So whatever the emerging technologies, suppose if you take the AR and VR, that related to the computer science more than to the mechanical engineering. Suppose if you take the IoT, that also related to the CSE field. Suppose if you take Industry 4.0, definitely the mechanical engineers and the that means the electrical engineers and the computer science engineers has to be worked with. So if you take a smart materials for manufacturing of the chips, ECE people are needed. That means electrical communication people are needed. At the same time, the mechanical engineer is needed. So everything is interdisciplinary, and integration is a key to drive the technology, and adoption is paramount. That means engineers must adopt their skills to remain relevant and pioneer new solutions. Otherwise, new technologies will take over our jobs. So adoption should be paramount, and the innovation should be in with a progressive mode. It should not be like a fluctuating mode and the passive mode. So innovation should be encouraged, and we should be ready to adapt whatever the possible innovation is existing coming. We should be dynamic to adapt the environment. So this is the session over the emerging technologies. People, if anybody wants to interact with me, you are open for the question and answer session. So thank you very much. The session is open for the questions. Yeah, Ashwini Sharma, thank you, ma'am. Nice presentation, thank you. So if anybody wants to interact, sir, sorry, sir. Ashwini Sharma, sir, thank you, sir. And
Thank you so much, sir, for your nice presentation.
yes, sir, thank you. So, yeah, I have a question. For Muthukumar, sir, VMT professor, for CNC machining, what kind of machine learning is useful? Sir, exactly, ANN is useful, sir. Artificial neural networks is useful. So the machining actually is what you are going to use for turning and drilling kind of applications. Artificial neural networks is very much useful, and that too for supervised learning. You have to go for the supervised learning. In the MATLAB also is supported with the some default modules itself. If you are unable, that means if you feel the solution right now what is coming, it is not reliable, still you could there is a chance to improve the neural networks technology also. So ANN is the good technology for such kind of manufacturing process. So artificial neural networks, and you have to go with the supervised learning. So first you have to go with the design of experiments. Design of experiments you should take, and after that you have to understand whether that parameter is crucial for such kind of experiment or not. Okay, so after that you can use the ANOVA. So not ANOVA, you can use the ANN techniques. Okay, so any doubts from the participants? Please So, so the session is open for the questions. And Padmavati Devi, madam, thank you, ma'am. Thanks for sharing your opinion over the presentation. Yeah, especially this is actually this session is comprised of different kinds of technologies, whatever they existed. So in the last session, I will teach you about the life cycle analysis, and by taking a real-time example, how the life cycle analysis should be performed and how it will be useful. So it will be like a practice session in the practice session for the last session, whereas this one is about broad introduction over the different technologies. So, Sandhya, are you here?
Yes, sir. Yes, sir. I'm here.
Yeah. If any queries from the participants are existed, you please collect that and forward to my mail. And you have my contact number also. You could send it, and I will try to answer them in person. So if the no questions are existed from the participant, means I can wind up the session.
Okay, sir. Thank you.
Mm.
Okay, sir. Hi, good morning. Thank you. Intelligence and engineering. Session.
So thank you very much, Sandhya, for assisting these activities and following my things. Okay. Yeah.
Thank you.
Yeah. Okay. So participants, if you have any queries regarding the current session, you could interact with the post-event people, and they will share the things, and I can resolve the issues in the next sessions also. Thank you very much for your kind cooperation, and have a nice evening.